So today we're going to be covering Day 5 notes, and this is about limit-based continuity. So there is a three-part definition that we use to tell if something is continuous or not. So there's 3 steps. If one step fails, then that means it's not continuous. So the first step is you have to show that f of a is defined. So in other words, when you find f of a, there is a y value that goes with that. The second step, you have to show the limit as x approaches a of f of x exists. So you're going to have to check the left side of the limit and the right side of the limit, make sure they're the same thing, and make sure they're a real number so they exist. And then the third thing is you have to make sure the first 2 steps are equal. So you have to make sure that f of a is equal to the limit as x approaches a of f of x. Okay, so first step passes, you move on to the second step. Second step passes, you move on to the third step. Third step passes, then that means it's continuous. If any step fails throughout this, you can stop and you can say it's not continuous because it didn't pass that. So for our first example, we have this graph here. So this is our graph of g of x, and it has a couple places where it's not continuous. So we have holes, jumps, asymptotes that we're going to look at. And we're going to use, and when they tell you to use this, this is when you're going to do this, the 3-part definition of continuity. Which is what we just talked about, the 3-part definition of continuity to determine if it's continuous or not. So the first one we're going to be looking at is that x equals -8. Okay. X equals -8, which is here. So if you want to go ahead and take a look at the graph there, we have a hole here. So it is not going to be continuous, but we got to show this 3-part definition. So for the first part here, it says f of a is defined. So we're going to see if what g of -8 is. Okay, g of -8, so at -8, point where it's defined is at 4, because that's where it's the filled in circles. So g of a equals 4. So because we have an answer here, that means that g of -8 is defined. So that first step passes. Okay. For the second step, we have to show that the limit exists. So to do that, we're going to have to do the left side of the limit and the right side of the limit. So we're going to do the limit as x approaches -8 from the left. So as you come in from the left at -8, that y value is -5. Okay, so then we're going to do the limit as x approaches -8 from the right. So as you come in from the right side, it's also approaching that y value of -5. So because these two things are the same, and because they give you a real number here, then we can say the limit as x approaches -8 of g of x exists. Okay, so because these two things are equal, and you might want to write out that they're equal, then that means that this limit exists. So step 2 is true. So there's step 3. Step 3, you're just checking to see if step 1 and step 2 are equal. So from step 1, we found g of -8 is 4. Let's just write this down. And in step 2, we found the limit as x approaches -8 is -5. So these are not the same value. So this is saying g of -8 is not equal to the limit as x approaches -8 of g of x. So because this one is not true here, okay, the first one was true, the second was true, but the third one's not, then because that one's not true, we can say therefore, and the symbol means therefore, g of x is not continuous at x equals 8. X equals -8. So this is the 3-part definition, and you have to make sure that you write all this stuff out. So for the first part, you're checking to see if it's defined. So see if there is a y value at that ordered pair. If there is, check it, move on to the next one. For step 2, you're checking to see if the limit exists. So to do that, you have to check the left side and the right side, make sure they're equal and give you a real number, and then that means the limit exists. Since that worked, we move on to step 3. Step 3, you're just seeing if step 1 and step 2 are equal to each other. If they are, it works, but in our case, they were not equal. So that means because this third part didn't pass, that it's not going to be continuous at x equals negative 8. Alright, so for the next one, we're going to use the same graph, but we're going to be looking at x equals negative 6. Okay, so negative 6 we're looking at here. So if you look at negative 6, we do have a continuous graph there. So our answer should reflect that this should be continuous. But we're going to use that 3-part definition. So for the first part, we're figuring out if g of negative 6 is defined. So we're going to figure out, okay, well, what is g of negative 6? Well, g of negative 6 is that y value negative 7. So we can say g of negative 6 is defined because we have that y value there. Alright, for step 2, we're trying to figure out if the limit exists at negative 6. So we're going to do the left side of the limit. Okay, so to do the left-sided limit, we're going to go from the left, and as you approach that negative 6, you're coming at a y value of negative 7. And then we're going to do the limit as x approaches negative 6 from the right. So as you're coming in from the right side, it's still approaching that y value of negative 7. So because these two limits are equal and they're a real number, we can say that the limit as x approaches negative 6 of g of x exists. So the first and the second parts are true there. So for the third part, you're checking to see if the first part and second part are equal. So we found from part 1 that g of negative 6 is negative 7. And we found from part 2 the limit as x approaches negative 6 is negative 7. So that means that g of negative 6 is equal to the limit as x approaches negative 6. So step 3 also works. So because all 3 parts of this work, it's defined, the limit exists, and then those two things are equal, then we can say, therefore, g of x is continuous at x equals negative 6. Okay, so that's the 3-part definition, and it was continuous there, so all 3 parts passed. Okay, so then the last one we're going to look at using this graph is x equals negative 4. Okay, so for x equals negative 4, we are looking at this point right here. So if you see at x equals negative 4, we have a jump in the graph. So it's not going to be continuous, so it should not pass our limit. So we're going to say, for step 1, we're figuring out if g of negative 4 is defined. So at negative 4, which is here, the point where it's defined, so the point where it's actually filled in, is at that y value negative 5. So we can say g of negative 4 is defined. So I'm going to stop for a second. When would it not be defined? If I would have had an open circle here and an open circle here, so there's no place where there's a closed circle, that's when it would be undefined. Okay, but when you have a closed circle, there's actually a point there, so that's when it's defined. Okay, so for step 2, alright, we want to figure out if the limit exists. So we're going to do the limit as x approaches negative 4 from the left. Okay, so if we come in from the left side, that y value is going to negative 5. And then we're going to do the limit as x approaches negative 4 from the right. As you come in from the right, it's approaching that y value of negative 2. Okay, so these two are not equal. So that tells us that the limit as x approaches negative 4 of g of x does not exist. Okay, because remember, for it to exist, they have to be the same number. And when we came in from the left, we were at -5. Came in from the right, we were at -2. So this one does not pass. So that means you don't even have to do step 3, okay? Because this one doesn't pass, now you can stop and say, therefore, g of x is not continuous at x equals -4. Okay?